Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on Prosper software. And today's topic is about matte acid design. Okay, so we will perform simulation and design of matte acidizing using Prosper software. Okay, so you can follow me as usual. We first by this section, double click, and you can follow me. Fluid oil and water, method black oil, spirator single stage spirator, no emulsion, disable PVT warning, and we will use default correlation for the water viscosity. And for the viscosity model, we select Newton wind fluid, flow type tubing flow, well type producer, method none, nothing special here. You can also type in the user information, company, field, location, well, platform, analyst, and the date. And for the calculation type, for the predict, we will select onshore or on land, or you can also select offshore in this case. Rough approximation, range, full system. For the brine properties, default, type case hole, send control, none, inflow type single branch, no gasconing. Okay, so we can click done here and we can follow the sections. All right, so the next one is the PVT. All right, so for the solution GOR 800 standard cubic feet per stock tank barrel. And then for the oil gravity 37, gas gravity 0.75, water salinity 25,000 ppm, no H2S, no CO2, and no nitrogen. We will select Glasso equation for the bubble point pressure, solution GOR, and oil formation volume factor. And for the oil viscosity correlation, we select Bill et al. All right, so for the other data, viscosity Newtonian fluid, the model, and no emulsion modeling. Okay, if you have data, you can also perform data matching. Okay, so you can input the laboratory data inside this PVT matching section, but we will skip this section for this case. All right, so we will concentrate more on the acidizing design. All right, so we can click cancel, cancel. Okay, from the PVT section, we will go to the IPR data section. Double click here. We check PVT data input, error, invalid data, gas gravity. Okay, we can close or done. Double click, something happened. Okay, oil gravity. Oh, we need to re-input 800. We need to click done actually. Previously 37, 0.75, 25,000. Okay, so we click done. Previously we click the cancel, I think. Done. All right, now we can go to the IPR data section, double click. All right, to select or to perform the simulation, in this case simpler. All right, we will select PI entry, so I just need to input the productivity index. So for PI entry selection, the reservoir data 500 or 5,200 psig with reservoir temperature of 210, water cutoff 0, total GOR of 800, automatically distributed the data from the previous PVT data section, and no compaction permeability model, no relative permeability. And for the model data, we just need to input PI information. This one, 5 stock tank barrel per day per PSI. Okay, so this is the original PI. And after we perform the design of acidizing, we will have PI after acidizing. So this is the initial PI before the acidizing, and later on in the stimulation design, we will get the PI after stimulation. Okay. All right. So from here, we can click calculate, and we get this one, AOF maximum flow rate of 18,277.6 stock tank barrel per day. We can also plot the results, x-axis variable rate, y-axis variable pressure. Done. All right, so this is our IPR, pressure on the vertical axis and rate on the horizontal axis. All right, click finish, done and done. All right, so this is the IPR. It's easy. And now we will go to the equipment data section, double click. We will edit the deviation survey, downhole equipment, and also geothermal gradient. And for the average heat capacities, as usual, we will follow the default numbers. Okay, so we click edit, deviation survey, 0, 0, 600. This is measured depth and true vertical depth. So you can follow my data. All right. You can see the cumulative displacement and the angle will be automatically calculated by the Prosper. All right. 7,500 at 9,000 TVD. All right. Click plot. So we have deviation or deviated well, finish, done. And now we go to the downhole equipment data section. Christmas tree at 0, and then tubing down to 1,000. The ID or inside diameter or internal diameter with default roughness and rate multiplier of 1. And after that, we have subsurface safety valve with smaller ID, rate multiplier of 1. And then we also have another tubing down to 9,000 with the same inside diameter and the same roughness. Lastly, we have casing at the depth of the bottom of the reservoir or at the depth of the reservoir with ID of 6.4. Okay, so we have a natural flow well. There will be no requirement to model the annulus like what we have in gas lift, for example, or suck rod pump or electrical submersible pump. In this case, we just need to concentrate on the tubing, right? Because we have tubing flow. Usually we have packers, so there is no need to model the annulus. There is no fluid flow inside the annulus, all right? So this is simple. We click done. Lastly, we need to input the geothermal gradient. At 0 depth, the temperature is 60 degrees Fahrenheit. And at the reservoir depth, the temperature is 210. We can also input the overall heat transfer coefficient of 8 and click plot. Okay, so it's simple. It's a linear gradient, linear line. All right. Straight line, finish, done. Okay. So far, so good. So from here, yeah, you can see the well schematic here. All right. And so from here, we can actually perform nodal analysis